Hi guys, this is Damni Jyal from Telecom Lead. Huawei launched a new testing as a service platform and proven tools based on a cloud architecture to provide automated testing solutions enabling operators to reduce testing costs and resources and accelerate new business development. Here we have Anil Rao, lead analyst, to speak about how to achieve agility in SDN NFV testing.
More detail about why do we need a different mindset for testing SDN services, and taking a step back in a sense as to why SDN NFV and the key objectives of NFV, SDN NFV, and in the context of testing, what does it mean? Let's make a start. So if you take a step back and to go back 5 years to ask a question, why SDN NFV in the first place? And initially there was a lot of discussion on, whether it's really a cost objective or is it really to do with, launching services quicker, faster, and so on. But eventually the industry sort of came to a conclusion that it's really around service agility, which is the main driving force to deploy SDN NFV networks and launch services. So the industry calls it as service agility, and this is a jargon, this is a buzzword across industries nowadays. It is really, under the bonnet, it's really how do you design and deliver new services as quickly as possible, and compared to the past, it's really around time to market for new services, not 9 to 18 months cycles, but really we're talking about days. Or even in real time in some cases. So service agility is a long-term driver for SDN NFV. So service agility, so this is based on a survey. The other key objectives are cost optimization and operational agility, but really service agility wins hands down. And this is how we see the whole evolution of SDN NFV taking place. To start with, currently we're looking at, this is broadly, if you look at a majority of operators today, they are still looking to virtualize network functions. And some operators are making the transition from phase one, which is virtualization, to actually orchestrating the network functions. And this is where really the automation of service design and delivery and operations comes into play. And eventually, we all want to reach a stage where all the network functions, the support systems, and the operational aspects of SDN NFV, they're all designed and deployed in a microservices-based cloud-native architecture, where operations and network, there is no real, there is hardly any difference between the network and operations. The lines are really blurred. So eventually, we want to get to cloud-native, but it's a long journey. So how do we get there? In SDN NFV networks, the key building block is a software-based virtual network function. An acronym we call it VNFs. And if you look at how the VNFs are designed, these are basically software building blocks, right? And the broad use cases that the industry is looking at, basically they're constructed using virtual network functions. So I'm trying to list here the broad set of use cases here. So from the right, the most hot set of use cases today are the enterprise services, which we all call as the virtual CPE. Traditionally, these CPEs have been boxes deployed at enterprise office locations. After virtualizing, we're going to have it basically a dumb box, if I put it crudely, and they're going to have software network functions deployed on these. A bunch of network functions that have already been virtualized or in the process of being virtualized. SD-WAN is the top use case. In the residential fixed services market, we're looking at virtual set-top boxes and a host of other network functions that are being virtualized. Moving ahead, in the mobile segment, we're looking at voice over LTE as the top use case, which involves virtualization of the IMS. And then as we move along, we get more confidence. We're looking at virtualizing the EPC, which is the core function, telecom app servers, and so on and so forth. Obviously, this is not meant to be an exhaustive list, but just to give a sense of what's happening in the industry. In the video and IoT services side, I've again listed virtual EPC deliberately because some operators are thinking about deploying IoT networks using a dedicated instance of virtual EPC and not necessarily share it with the traditional mobile networks. And we've got, again, a whole host of other virtual functions. And there are a bunch of others, the virtual router itself, the switch on the transport. So virtual probe is another interesting example of this is actually an operation system, which is also being virtualized. So the industry is moving in this direction. There is a lot of progress being made. And the potential for use cases is really endless. But the challenge, if you take a step back, and in the context of today's session here, SDN NFV creates new requirements, and it has an impact on a broad set of functions in the operator. And without getting into too much details about a lot of other aspects, operations, and there is a lot of complexity there. But today we're just going to focus on testing. So what does SDN NFV mean for testing? Three broad problem statements that I've tried to explain here. We don't have time to go into a lot of details in other aspects. But really, we're looking at the interoperability requirements due to the increased network complexity. I'll come to this. I'll come to each of these in more detail in a little bit. Requirements around life cycle management, because DNFs are, can be dynamically controlled. They have its own life cycle states. So what do you do with it? So here's where orchestration comes into play. I'll come to that. And continuous delivery and integration, because if you look at the enterprise industry, where innovation is much more fast-paced, we're talking about cloud-based architecture, microservice architecture, and so on, where software functions are being developed as tiny microservices, which helps the enterprises to rapidly develop those services, rapidly interconnect using APIs, and deploy them in a much more rapid manner compared to the past.